Okay, so this is video number 195. It is still Thursday. It's 10:44 p.m. Thursday, March 18th. We're working on a zodiac table. The Capricorn symbol is up next. That's what we're about to work on. And before we get to it, before we figure it out, we want to do a quick internet research to think of what are the variations and what is the underlying structure of this? Like, what kind of underlying structure is in here, right? So we notice that, oh, this kind of looks like sea goat. Okay, that's weird. So this kind of looks like a little V and then a whoop, right? And this looks like an N. So those are two completely different stylizations. Now, I don't know which one is more common, right? So to figure out what's more common, we're just going to look through images really quick and see what seems more common. So most of the time it looks like we have this kind of N kind of a thing, which is actually going to make things a lot easier to work with if it's an N rather than this V-ish kind of thing. Yeah, so like this. So this is, so out of all the kind of designs that we could have, in terms of very simple geometry, this one looks like a winner, right? I can see the underlying geometry pretty well. So we're going to look at this for reference, I think, when we're trying to like rebuild this, right? So, we've noticed that it's kind of like a part of this symbol looks like it's part of a Virgo or a Scorpio. There's kind of that similar geometry. So we could keep that in mind as we're trying to draw this. So we're gonna like make 3 circles, and we're going to make them, and then we'll chop them down. And a lot of this is going to be a lot similar to like how we made the Virgo symbol, right? All the workflow for the Virgo symbol is kind of going to be in here. Now I don't know about this kind of swooshy thing. I don't know if I can do. So we have to do that kind of swoosh. Can we do like can we do a 45-degree line and then immediately go, right? So 45 and make a little sharp angle. I think we could get away with that. That would be easiest for us to do because we don't have any splines, right? We don't have splines to us, so judging by what we can do, we're going to try to do a 45-degree line and then maybe a little tail, right? Okay. So now that we've kind of thought about this and looked at some source material, we're ready to get things going here. So I am getting a little bit tired, but let's just try to I really would like to get all of them done. So first of all, let's go into this cutting file, right? Let's go into the cutting file, copy paste, and this is going to be the Capricorn, right? So we're going to call this Capricorn code, and these are the things that need to be changed. So over here, let's just change them all really quick. So Capricorn code, right? So Capricorn code, move this over here. Okay, and then this is going to be cap for Capricorn, right? So abbreviate the first 3 letters. We're not going to try to think hard about how to abbreviate it, right? We're just going to take the first 3 letters, and that should be enough to get what we need done, right? So then right here, this is going to be Capricorn, right? And then we just want to refactor all these points right here. So we're just going to say all these things, just change the name, right? Maybe align this nicely, and say, okay, we're ready to go there. So let's close this, and then let's also open up this and create the files that we're going to use to create the SVGs. So let's start off with, Capricorn 01, right? And save this as within the zodiac table in the cutting files. It's going to be called cap001.scad. And then we'll create the other boilerplate kind of thingy, right? So this is going to be cap02. Save that. cap002.scad. Cool, we got that. So we got cap2. And we got cap1. Excellent. So now we have kind of like most of the stuff in place, but we've got to turn the debugging on for this. And then down here, we're going to make another section for Capricorn code, right? So we're going to say cap code. We're going to call it Capricorn code. And then we're going to okay, so in here we're going to say module, right? Module ZODIAC Capricorn, SBC Capricorn. Okay, and we'll start doing some stuff in here. We got to open up that file though, so we're going to open up the main file that we're doing all our work in, and we're going to top view it. Okay, so the symbol is going to go inside this wheel, right? So as we're coding, we got to think about that. So we need to figure out the radius for these things. So we're going to use just one radius for all of the circular pieces of geometry, because the more consistent it is, just the better it'll look in a design sense, right? The more happy coincidences we can have here. So we're going to say Capricorn symbol consts. Right, we just want to keep a consistent convention here, and this is how we've been doing it. Okay. And then for here, we're going to say ZOT Capricorn, and then rad, or radius. Oh, but it's imperial radius, right? So the radius is imperial. And that equals what? What does that equal? It equals like, I don't know, we could try 2, we could try 2.5, something, I don't know. And then we have some other things like a leg length. And we might want to look at the Scorpio, right? We want to look at the Scorpio symbols, because those symbols, we might want to have values similar to that. So where the hell are they? Oh, no, because it's Virgo. So the Virgo, so this length right here, that's not actually the length we want to do. So we don't know what that is. So let's go look in here for a second and find, at some point we had decided on some type of length for this triple M thing, right? So we look in here, this pocket is DT, and it's the diameter plus the thickness. This is cleave, difference, union, IX, SBC, radius. This is the wheel. This is the brass knuckle top. Okay, these aren't the legs. This is the legs. Okay, legs. The lines, thickness, P1, P2, radius times 3. Okay, so the radius times 3. So whatever that radius is, Virgo imprad times 3. Okay. And Virgo imprad is what? Virgo imprad is that. Okay. So, do we want Virgo imprad, or do we want to multiply by 3, right? So, ZOT Capricorn imp len of the legs. So let's just say times 3 for now, right? Leg length. So let's just start off. We can adjust it as we see fit, leg length, but I just wanted to see what we did for other values, right? So first we're gonna God damn it. So we're gonna take this, copy, and we're going to go all the way down here. And inside the Capricorn, we're going to make some shorthand variables for this, right? So this is kind of an obnoxious. So we're just going to say, you know, rad equals this and length equals that. We're not even going to worry about the fact that it's imperial. We're going to keep it very shorthand, right? So this is circle, wheels. This is the wheels, and then the legs. Those are the variables for those different attributes. And if we run this, hopefully we didn't introduce any syntax errors. Nope. Okay, cool. So the next thing is just getting these shapes into place. So let's just do like a V-carve inch wheel, SBC, the radius. So we have a radius, and then we also have a thickness, but we need to find that thickness variable. So we're using the same thickness variable, which is the thickness to use for a zodiac sign, right? So let's steal this, and we'll probably also need this pretty soon as well. I see it in my future. So let's steal all that, and then maybe cluster that together or whatnot. I don't know. Okay, and then let's just view that for a second. F4. What do we got? We got nothing. What did we screw up here? So this is Capricorn. Oh, because we still have to actually call it, right? We got to call it ZOT SBC. Call it with the configuration variable. Okay, give that a look. Give that a run. Okay, so that's kind of like right in there. That's way too big. Also, is our sound on? Yes, our sound's on. So we want something a little bit smaller, right? This radius, way too big. So if we go find that radius, 2.5, like, I don't know, like maybe 1 point, no, maybe just 1. Let's just try 1 for a second, F4. Yeah, 1 might just be big enough, because we have these two things. And then what I'm thinking is, we have this kind of tangency between these two. So let's put a breakpoint here, so we can kind of go back and forth between these things. So I'm thinking we have this, and we do like inch x SBC 0 minus the radius, right? And then on the other end, right, we make one more of these. And then instead of 0 minus the radius, we do 0 plus the radius. Okay, F4. So now we got these two kind of circles here, right? And that's a little bit too big, right? We're not going to have much room for anything if the radius is that big. So let's go back up to where we define that radius and say, no, that's not going to work out for us. You know, maybe we could do 0.8, maybe. I don't know. Let's just try it and say maybe that'll work, right? And the next thing is, in terms of like where these pieces need to be. Let's go look at that for a second. So F2. I'm thinking that we can just move this up and move that down, and then okay. So let's just do IY for a second. So vertical distance between the circles is going to equal, I don't just want to tangent it, I also want to do, I think I want to do like rad times 2 maybe. Vertical dist between wheels, okay? And then we're going to do like a IY, and we'll do SBC 0 plus the vertical distance, right? And then for over here, we're going to take the same IY offset and inset that. And for the IY offset down here, we're going to minus, right? Okay, F4. So is that a little bit too far? I'd say that's a bit too far because it's tangenting the borders, right? We can't tangent the borders, so we're thinking maybe 1 times 1.5 maybe, and see what that looks like. So that is maybe, actually no, that's perfect. That's about a 1/4 of an inch gap, so it's really close, but it's about a 1/4 of an inch gap. But the problem is that this circle here is not the end of the zodiac symbol. There's a little tail that needs to still be here. So the 1.5 is not going to work. We try a 1.2. So 1.2 looks good. Actually, could we do rad plus the thickness, I guess? Let's try to make kind of happy coincidences here. Or plus the thickness divided by 2. Okay, right, like that. And then, that's still going to be too big. That's still going to be too big. So we got to go look at this imperial radius. And it's like 0.8. We got to make it like 0. I don't know. Let's try 0.6, F4. Not a fan of this, but I how about 0.7? Let's see, or 0.75. Let's try that. Like a 3/4 F4. Yeah, because this needs to go off the wall. No, 0.77, I guess. Let's try 0.7 F4. Okay. So before we kind of guess around some more, let's go put the other wheel on, right? So if we look at this, we have kind of these offsets here, and we got this wheel here. And so within this section, here, we want to do something on the X. We want to take this, and we want to make one to the left, right? So one to the left, so minus rad, rad times 2, maybe? We want to, here, and want to go plus the diameter, right? So, the radius plus the diameter, so RD, RPD, radius plus diameter, we want to call it. Let's call it radius plus diameter, equals rad plus rad times 2, radius plus diameter. Okay, so with this RPD thing, we're gonna say boom right there, right, and then go F4, and say, okay, yep, that is where we wanted it to be. And now we want to kind of cut it in half, right? So this thing, we want to go difference, right? We want to take this shape. So actually, the difference needs to be in here. That would be easiest to work with. So we're going to take this shape, right? And we're going to do a difference between the circle that we've already drawn, and we're going to nuke half of it, right? So we're going to say that we need a vcarve inch pocket, SBC, and we're going to do the diameter, let's say diameter and 0. And we don't have a diameter variable, so we need to make that. So this thing here, we could say diameter equals the radius times 2, right? And with this diameter variable, we can just see what that looks like. F4, right? It might nuke out the whole thing. Well, it nuked a lot of it. So with that diameter, it's not quite right because we need the thickness in order to encompass everything. So let's do that. So this thing needs to be this SPN, the span equals the diameter plus the thickness. Yeah, plus the thickness. And so using this span, we can just nuke out the whole thing, F4. And then we want to change the center point, right? So change the center point so that we can actually see what we're doing. And so to do that, we just want to go take this, and let's just put this at the top, right? Let's not worry too much that it's a very generic variable name. We want to move this by inch x SBC 0 minus, and the span, we want to go span divided by 2, because we just want to change the origin of the rectangle to be on the right edge of the rectangle. So if we do that, F4, right, now we're nuking it kind of right there, right? So that's pretty good, except we have one more problem, which is this bottom part needs to be nuked as well. So to do that, what we could do is we're going to have to create a union in here, right? So we're going to have to create a union, and this is the geometry within here. We're going to have to combine more subtractive geometry, right? So we can take this right here, and we can say, oh, well, instead of just being on IX, we could take this and go on IY, and that might be all we need to do. So F4, take a look at that. So bam, nice, that looks good. So looks even better than I thought it would look. Okay, so now we want to subtract down here though. Now we want to slice that, right? So we need another thing. Now, are we at the center of, this is SBC. So yeah, what we could do here is we could do IY. Oh, this is the wheel on the tip. Hold on. So this wheel right here is that little tip thing, right? And this is the... So hold on. So this one, top of the N. Okay, so this is the top of the N. Okay, F4. So to fix this, we can just go difference. And we will subtract, we'll do int y, we'll move it on that y, SBC, minus 0, minus the span, I guess, still, or no? Yeah, minus the span divided by 2, so same kind of math here. We'll put that in there. And what we want to do is this kind of pocket thing. So we're going to take the same exact pocket, put it right here. Okay, F4. Okay, cool. So now that's all good. Now we gotta draw a line from here to here, and we have to draw a line down to here as well. And then we have to come up with like a some type of 45-degree kind of thing that's coming off of here, right? So 90 degrees is going to tangent right here. 45 is going to tangent right here. We have to figure out where that tangent point is coming from as well. So let's just tackle the hardest part first. Let's tackle the fact that we got to figure out where this point is, and then we have to go all the way to the center. Or not to the center, but we have to go to here. Or where do we have to go to? We have to go 45 degrees until we hit right here. Right? Now we have to go... Oh, I see. So for all this math to work out, we need... Oh, we need to go here. That doesn't quite line up, does it? Well, maybe it does. Hold on. So I'm trying to think that we need the point to be right here, in here, up or down. And then we also need to be tangent with this, right? So we don't control the degrees then, right? We're not controlling the degrees. We're saying we want a line that tangents the circle, but we also want to go through this border here. We want it to tangent the circle, and we also want the line to... We want the line to just go through... So I'm thinking what we want is the line to go through this point right here, right? So we want a line from here that goes through here and tangents, right? We want to start the line right at this point right here, right in the middle. And we want it to tangent this shape. So we don't control the angle. We just want to get some nice tangencies, right? I'm thinking that for getting that to work correctly, I don't know what degree that needs to be. You could just try like 45 degrees, right? And that just might be good, right? Because it's on the midline. So like 45 degrees, and then we just make that go up, right? Okay, let's just try that and see what that looks like. So F4, and let's go find that last wheel. So this is the wheel on the bottom, I believe, right? So let's open this up a little bit, and let's comment this out to make sure that that is what we're working with. Actually, let's move this over here like this. Okay. Okay, and comment that out. Make sure that is the circle we're working with. Yep, that's the circle we're working with. Okay, excellent. And we want to just put something right here and just have it work. Okay, let's say we have kind of these transforms, right? So to get to the center of this circle, we need these transforms, right? So we could just say bottom circle equals a little vector coordinate, so the bottom circle coordinate, right? And on the y, it's this calculation, right? And on the x, it's this calculation here, right? That's what's getting us. That is what's getting us the points, right? So F4. We haven't changed anything yet, but now what we can do is we can say this right here can be BC 1, right? Because it's the y-axis. And then over here, we could just, let's just get rid of that extra nesting, right? And then what we'll do is this will be BC2, right? So BC2, or not BC2, but this is the x, so this will be BC0, which we did it kind of in a backwards way. But let's not worry about the fact that everything's backwards. Let's just worry about the fact that, hey, it's still in the same exact place. Okay. So now that we have that, it's a little bit easier to just kind of put a point here, 45 degree it that way, 40 and 90 degree up that way, right, to get it to where we need it to be. So let's do that. So let's take a V-carve inch line, right, SBC, and then we're going to say the thickness, and then we want to start off with 2 points. So we want BC as the first point, and then we want to do tip chord. Tip chord, we could call it TC for tip chord. So BC is bottom circle center, right? And then if we want to do the other TC, so TC, right, is TC is tail tip coordinate, something or other. And the tail tip is going to start off with BC, so BC plus something, and then BC plus something here, right? Some trigonometry here. And we'll need the cos of 180 plus 45. Okay. And then also we need to multiply it by some type of length, and I don't know what that length is yet. Do we have a length variable? We have this kind of length variable here. This is for the legs, so it's not for the tail, right? So for the tail length, we'll just do I don't know, equals 0.5. Tail 45 deg. I don't know, T4L, I don't really care. Just get a variable in there. And then over here, right, we're going to scale it by that, right? And then over here, we're going to do the same stuff, except this is the sign now, right? And with that, let's just make sure that this point, well, actually we're done, right? We just got to draw that line and see if it's drawn correctly. F4. So we made a syntax error, so that sucks because now we got to hunt that down. Oh, well, first of all, that's not a square bracket at all. That's why. F4. Okay, cool. So this degree is wrong, right? So a lot of stuff is wrong here. So this BC is in the center. And is that correct? Is that where we wanted it? Yeah, that is actually where we wanted it, right? We actually did want BC in the center. But we want to get something over here, right? So let's say for this we actually want like a left tangent. So LTN left tangent. And that left tangent is going to be some type of math like this. So let's steal this. And then instead of going this, we're just going to do this, right? 0. And then instead of this, we're going to go by the radius, right? To get right here, right? For this BC. And then this is going to be based on LTN instead, right? And so we got LTN and TC. So this is going to be LTN and TC. Okay, so F4 that. Oh, because the tangent is right in here. And then we did 180. We did 180 plus 45. We want to do 180 minus 45. My bad. So 180 minus 45. Okay. F4. And nothing. LTN. So is this the tangent? Is this the tangent here? Like if we just do this, do we get that tangent point there? Yeah. So that's the tangent point. And we changed the degrees, and we got nothing. The degrees did not change our lot in life here whatsoever. So let's comment this out, make sure that that actually has an effect first, because like that could happen. So then the question is, what the hell are we looking at here? What is that dot then? It's the whole damn thing. Okay, hold on. What the heck? We just deleted that thing and then, like, everything went, right? Okay, so something's not refreshing correctly. Because F4... Okay, so this thing here. If you comment that out, we gotta do F4. We gotta remember to do F4. So that, so this is the tangent. And 180 minus 45. Well, what are we expecting? We're expecting something way down here, right? How about 180 minus 90? Let's just try something. F4. F4, and then, it's just not moving. It's just absolutely not moving. So what is this T4L? Did we screw this up? 0.5. That's a length variable. Well, first of all, this tangent thing isn't quite right. This radius, is the radius not correct? What is the radius? Imperial radius. So hold on, okay. So where's BC? Where's BC in all this, right? So if we do, let's just put BC in here for debugging for a second. So BC, is BC correct? BC and BC, go, just put that over there. F4, is that in the center? Yes, that's in the center, right? Warning, transformation matrix contains not a number or infinity. Okay, so at some point, we have screwed some stuff up here. I don't know what it is, but BC has some type of bad math in it, right? So, plus radius minus VD VIL, missing some parameters. Oh, wait. What are we missing here? So it's this thing here. The BC value is somehow corrupted, right? Like if you do F4 here. So the BC value is somehow bad, and it's creating problems for us, right? Is that what's going on here? Okay, this sucks. I don't know what's wrong with this. I don't know what's wrong with this math here. Because it looks fine to me, and I'm like... BC... let's just say if rad... if not rad greater than or equal to 0, or rad less than or equal to 0, echo bad rad, oh no, right? Okay, if VD not VD, or VD less than or equal to 0, echo bad VD, oh no. Okay, let's put that in there, F4. And we don't see anything that's telling us we have a problem, right? So this is BC. And is it possible that we are creating these outside of the scope? No, that looks okay. So cosine, the cosine of something times like a radius, plus, oh, wait. This is where we're screwing up here. Those need to be x and y. So this LTN, same deal. We need the x and y's. Okay, so we probably screwed that up in many places. Okay, there we go. Okay, so let's try that. So F4. F4, I said. Okay, F4. Okay, so now we got a point right there. So the tangent and then the tail tip coordinate, right? So let's comment this out. So, okay, so I see what I missed. Okay, so this is kind of like, we probably screwed up the calculations here because we were guessing, we're like flailing a little bit. So 180 minus 45 degrees, actually plus 45 degrees because of the rotation. Okay, so now F4 for a second and see what that looks like. So that's like, not quite right. Like at here, the angle we need for a tangency, if we're right here on the circle, we're gonna need to actually be like 90 degrees, right? So if we want a 45 degree tangency, then we have to make this point not here, but we need it to be 45 degrees right here. So if we look at where we're on that surface, right? So the line tangent part, we see 180, right? We're using 180, so we want to do 180, and we want to do 180 minus 45 to get a tangency that looks good. So do that. Let's do F4 and see what we have there now. And so now that's tangent. That's nice and tangent. And now we need to make it a little bit bigger. So this this tail length, let's increase that by, I don't know, let's make it 1. Okay, F4. Right? And then I'm thinking even longer. I'm thinking 2 maybe. Let's just say try 2. F4. Oh, that's a little bit too long, so maybe 1.5. F4. That's still arguably still a little bit big. So maybe like 1.25. Okay, that's pretty good. And then we can put a little now actually I see some this kind of like goes down. If it could tangent, right? If it could be the correct length to just do a tangent, that would actually be kind of nice. So let's do 1.5 again and see where that ends up with F4. 1.5, 1.75. So that actually gives us almost a tangency, 1.7. Yeah, like 1.7 looks pretty good there. Now that is kind of long. That is kind of longish. So maybe it's not good. I don't know. But I like that we could get kind of a now maybe we want just a steeper angle, right? A steeper angle could fix our problem there, right? Because then it wouldn't go out as far. So with this here, we could say we have this minus 45 plus 45. I believe to get the tangencies working, we could just say tan maker equals, and instead of 45 degrees, we could try something steeper, right? So we could try 60 degrees. And then let's just throw this in here, and I think that'll still be tangent. I don't know for sure. I'm taking some guesses. I'd say that's not tangent anymore, is it? Well, it could be... How did we get this point up here? So we got this point up here. So first of all, let's do 45 again. F4. And maybe there's a different relationship that can get the same number that's actually more appropriate. So we're thinking we have a vector coming off here, right? And that vector is perpendicular to these vectors are somehow perpendicular to each other, right? So this is 180 plus the tangent, so 180, hold on, 180, hold on, 180, okay, so 180 is here, and then we're minusing the 45. Can't this just be 45? F4. No, because that's 45 there, so it'd be like 90. 90 plus 45. Right? And then, in terms of the angle coming down off of here, we want it perpendicular, right? We want it perpendicular, so that means it's going to be 180 plus tan maker. Oh yeah, because another 90, right? So if we do that, now if we put a 60 in here, do we actually get the, do we still get a tangency, right? Okay, so now we still have a tangency no matter what we do here. Okay, so that steeper angle, I think, is what we're going to go with. Just so that we can make this kind of more interesting, I guess. So this is still a little bit too much of a tail, I think. So let's go back to this tail stuff here, and this 1.7, let's make it a 1.5 again. And F4. We're going to put like a little hook on it. We're going to put a little hook on it still. But that's good there. And we want to connect this dot here to this dot to this point right here, right? So we got to figure out where those points are. And I don't know where those are. So we need to look at the wheels. So these are the wheels. And is this the wheel? This is the top of the N, right? So this is the wheel we want. And to get to this point, we'll say top of N equals 0 plus VD. Oh, actually, no. Top of N equals 0 plus VD, right? So the y-axis for this wheel shape. Okay, and this is the x-axis offset. So we're going to take those. So, top of N. Okay, put that in there for a second. And then what we're going to do is we're going to do some substitution. And for the y-offset, right, for the y-offset, this plus VD, we're going to use the y-axis. And then for the x-offset axis, we're going to do the same thing, but it's going to be the first parameter, which is the x, right? So now if we do this, F4, we still have everything in the same exact place, right? And now we can use this variable to locate, actually this is not the top of the N, this is center of it. This is the center of the N, right? My bad. So center of n, right? And so this isn't going to work because we mangled our parameters, but I just wanted to see that it did have an effect, right? So F4. So yeah, that was the center of the n, right? Because that we're translating this. And so to get this point over here, right? Left of n equals, it's the same value on the y, but it's con dot 0 plus the radius. And then on the y, it's just con dot, the y hasn't changed, right? Left of n. Okay, let's go F4. We made a mistake somewhere in here. Because that's a square bracket. Okay, F4. So now, with this thing here, this is this point right here we are assuming. And so let's just connect those dots, right? So connect those dots. So we should be able to go V-carve inch line, right, with this thickness. And then we should be able to use the new thing and then go to the tangent point, right? And if we do that, we should have a line connecting where we want to connect. So it's slightly bent, though, right, because of that tangency, right? It's slightly bent, and I don't know if I like that, right? It's nice that it's there, but no dice. So we're going to say, instead of this tangency point, this is the center, right? So we want to say, you know, we just want to say BC minus the radius, and then on the y, it's just the same. And if we do something like that, I think it'll look better. So F4. Okay, so something like that, right? And so now, yeah, that looks much better, nice and aligned. And then we also want to make a leg. So this is the right leg of n. And we want to make a left leg of n as well. So we want to make a left leg of n. And I don't know exactly what that needs to be. But what we could do is we could take all this math and we could just translate it, right? We could just take all these calculations. So draw legs. So we can get in here. And we can start kind of like making some variables for what that needs to be. And this code is a disaster, but the idea is just to get something that works properly. So this is going to be so the n left leg, right? The points for that are going to be these things right here, like all this, right? Or actually, the left point 1, right? Left point 1 is this, or is God damn it, lawn. Okay. So the first point for the left, and then the left point number 2. So 0 and 1 for the left. And for point number 2, A to B, left A and B. Left A to B is what this is. And for the, let's steal that, right? So for this, it's this, and then it's the BC1. Okay. And let's just make sure we haven't introduced any syntax errors yet. Okay, cool. And then what we're going to do is, this is actually the right? This is the right leg. So this actually needs to be R. and F4. Okay, so still no changes. But now, instead of using kind of this mess over here, right, we're going to do RA and RB. Okay, F4. Okay, so still the same kind of stuff, and then we're going to duplicate this, and we're going to do the left, right? So we did the right, so now we're going to do the left side, so LA and LB. And we should put this over where we actually want to put it. So we want to put this over here, right? And to get this, we just need to translate it, right? So let's copy this and then make this L. And then the L is going to be... oh, I see. So we do the right, left. We do the right first, and then we do the left because of their relationship to each other. So the left is based on the right, right? So what we're going to do is we're going to say, oh, we're going to take the coordinates and we're just going to translate them by the diameter, right? So we're going to say RA, right? The first point of RA minus the radius times 2, right? The diameter. And then on the y-axis, it's just RA. We don't even change it, right? It's just it's the same value, right? Okay, so now if we do that and we go F4, we got something, but it's not exactly what we wanted, is it? And why is that? Because this is RA when this should be RB down here, right? Okay, so now if we do this, F4, that's correct. Now, the next thing we want to do is just forget about this kind of like that roundedness. No, we're not going to round the tips of these lines. So we're going to make those zeros. And then F4, and that's looking better. And the next thing we want to look at is trying to get like a little hook here, right? So we're not going to try too hard. We're just going to like go make a straight line, right? Just so that, yeah, we're just going to keep it kind of dead simple. So first of all, we have to figure out where that's coming from. So I believe that is this thing up here, right? So if we do this and yeah, so that's the tail thingy, right? So we'll just say in here, we're gonna say draw inner tail. Inner tail, yeah, sure. We'll call it that. I don't know what else to call it. We'll just call it a tail, because this is kind of abstract, so some of the comments are kind of complete nonsense, because we don't really have anything to... We just have to use our imagination and just go with something, and it's gonna look like absurd nonsense, but it's better than nothing, right? So, F4, we got this little tail thing, and we're thinking we just want to extend it so that it kind of tangents with this point here. So, how are we going to do that? I don't know how we're going to do that. So, we have this kind of, this is the tail tip, right? So, we're thinking that we want to do something like this. We start here, we have a thickness, and then we start off at the tip, right? So, we start off at the tip, and then the next point is going to be like we want to do something like the tip, the TC, the tip X, and then we just want to minus, I don't know, 0.5 or something. And then for the Y is the same. We haven't changed it on the Y, so it's just nothing. There's just, you know, plus 0. Okay, so now if we do that, let's go F4 and see if we have like a little thingy. Yep, we got that little thingy. And if we remove the, well, I do like the rounding right there. The rounding there is kind of nice. Oh, there we go. Not bad, not bad. Like, now, I would like to kind of clean this up just a little bit. Or actually, no, that actually lines up pretty well. It might be like, you know, we could probably do like minus 0.48 if we really wanted to be a perfectionist here. But that's actually 0.49. F4. Yeah, so really... to get that kind of perfectly aligned... So we can see some red here, we can see some red here. Yeah, so that's pretty well aligned. That's pretty well aligned. So I like that, right? It's a little bit kind of weird angle-ish, but it works, right? It's not perfect, but we can just say, you know, the other styles that we've rendered so far have like weird angles in them. So let's just do that. Let's do that, call it a day, right? So the next thing we want to do is all this code we've written so far. First of all, let's just steal this name right here. Let's steal the name, right? And then we're going to call this one right here. We're going to say non-centered. Right, so this is the non-centered version, right? And then we'll put this over here, and we'll call it here like this, SBC. And then we'll just add some tweaks to center it, right? So, for doing that, first of all, I don't think we ever used imp native, did we? Let's not worry about it. So, inch IXY, SBC, what do we want here? I'm thinking that we're pretty good here. It'd be nice if we just could move this over to the right a little bit. So I'm thinking IX SBC, and just move it over by the thickness divided by 2, and see if that looks good enough, because then we have the most kind of happy coincidences with how everything has been lined up. So thickness does not exist, so we got to go grab that. So this is the variable for thickness, so we'll grab it, we'll put it over here. Okay, now let's take a look at that, F4. So with that there, that's not too bad. Unfortunately, it's a little not so good right there. So some ways we could kind of fix that is we could make this radius bigger, but I don't see, that would just make it look a little bit awkward, I think. So I do like it there, though. But I don't like how it's kind of this far off here. So, well, let's look at that. Well, first of all, let's go look at some more zodiac symbols, right? For Capricorn. And let's see if there's any one where this second loop is a little bit bigger, right? Because I could see that making it a little bit better in terms of... so this thing, loop, smaller loop, smaller loop. Looks like a no. Like, we could do away with that proportional relationship and see if it just looks better. But even if we did, if we look at this is already too close over here, right? It's like, ooh, back off, right? So, you know, unfortunately, I'm thinking the best solution here is just to move it over a little bit. So, plus, so thickness divided by 4, I guess, instead. F4? Or actually, sorry, thickness divided by 2, divided by 1, right? F4. Yeah, like that's just better centered. Yeah, that's just better positioned. I don't like how this midline right here, I would like this line or this line to line up with it. But we gotta, I think that's less important than having this gap here and this gap here, right? Just having it kind of correctly positioned here. So that looks good to me. I think that's kind of like where we want to keep it. So let's remove this kind of code here, the debug code, the code we're using to produce this. Let's go turn this debug flag off, right? And now this file looks completely empty. We'll close that, and we'll go back to our cutting files, and we'll go render those. So in here, we should already have the Capricorn stuff ready for us. So in where is CAP? Do we have the CAP? Where? Okay, let's go F5 to refresh, because I think the alphabetical order is not here. So Capricorn, right here. So we're going to take this, and that took me longer than I thought it was going to take me. That's because we got stuck. We got confused on something, I believe. I don't remember what it was. Okay, so File, Export as SVG, and cap001.svg. Save it. Okay, we'll close this now. We'll go to the second file, which is just the peg holes, and we'll render those just for consistency. File, export as SVG, and this is Capricorn002.svg. Okay, Then we'll close this, and then we'll F5 this to refresh and look at the Capricorn files. And we want to look at this SVG rendering. We just want to take a quick screenshot of it so that we know, so that we can just take a quick screenshot of it so that, I don't know. Oh, because we want to put it in the root folder of here so that we can have a quick overview. We want to be able to have a quick overview of everything we've done, right? So, so when we're going in here, right, and we want to look at like all the ZODIAC symbols we have, but if the code breaks for some reason, or if it's just a pain to go run the code, to flip through all this stuff, right? To flip through all this stuff would be very hard in the code because we'd have to execute one function, check the result, execute another function, check the result. It would be annoying. So taking these kind of snippets kind of helps us. So we have 2 more symbols to do. So Aries, this is Cancer, this is Capricorn, Gemini, Leo, some type of scale, Libra, arrow thing, bow and arrow, Sagittarius. This is Scorpio. This is a bull, Taurus. The ME is Virgo. And yeah, so those are all the symbols we have so far. And we're going to keep on cranking symbols out. We have 2 more. We have 2 more to do. And I'm kind of tired. I could eat some food, but I just feel like if I eat some food that I'm not going to get any more work done, where I'm just going to be like, eh. And the next symbols are really easy, right? The Aquarius seems slightly difficult, but the Pisces seems pretty easy. So I think if we use like a zigzag kind of Aquarius symbol, it'll be easy to do. So we're going to close this, and we're going to git bash here. We're going to commit the work we have, and then we're going to think about how we're going to do the Aquarius and Pisces symbols. So git status. Okay, git add dot. I don't know why this is taking so long. I need to start a timer here. So it's 11:46 right now. Or actually, no, I have a timer right here. So 102 in the stream. We kind of let's assume we started at about 102 in the stream, and this is taking how long? Is this taking a whole minute? Okay, and then git status. Git commit -am done Capricorn. Okay, and then more delay, so I don't know why. Okay, so git push GitHub master. And then, I don't know if do I want to go eat the food I've been waiting on, or do we want to get these 2 next symbols done? Okay, here's what we're gonna do. I don't know what we're gonna do. We're gonna stop the stream, first of all, because we're on a new symbol. And we'll restart the stream maybe immediately. Maybe we'll go eat some food. I'm not sure. I'll think about it after I look at some of the symbols really quick. So I'm going to stop the stream, and I don't know when I'll be back. I'll think about it.